Hello students, I hope you all are doing good. Let us start with our next session of surface areas and volumes. This is the fourth and the last session of this chapter. Let us see what are the learning outcomes of this session. Introduction to the concept of frustum of the cone. You will also learn the formulas for volume and surface area of the frustum of the cone. Also, we will apply all these formulas in the real life situations. So, let us revise a few concepts. This is a cone and we have already studied about the volume of the cone. It is 1 by 3 pi r square h. Here r is the radius of the cone and h is the height of the cone. Also, curved surface area of the cone can be given as pi r L. What is L? L is the slant height. This L is the slant height of the cone. Similarly, the total surface area of the cone can be given as pi r taken as common r plus L. So, let us see what exactly a frustum of a cone is. These are the live examples you see in your daily life. This is a bucket, a glass, a cloth basket, a sand bucket as well as a dustbin pan. So, let us see what the formulas of a frustum is. This is a frustum. See, a part of the cone. This is a frustum, the lower part of the cone. So, volume of the frustum of the cone can be given as 1 by 3 pi h r1 plus r2 square plus r1 r2. Now, what is r1 and r2? r1 is the smaller radius and r2, this is the bigger radius. L is the slant height and h is the height. So, volume of the frustum of the cone can be given as 1 by 3 pi h r1 square plus r2 square plus r1 r2. Okay? And curved surface area, the curved surface area can be given as pi r1 plus r2 into L. What is L? L is the slant height of the frustum of the cone, where L, the formula of L is under root of h square plus r1 minus r2 whole square. Similarly, the total surface area of the frustum can be given as pi r1 plus r2 into L plus pi r1 square pi r2 square. What is r1 r2? r1 is the smaller radius, r2 is the bigger radius. Pi r1 square, it is the area of this portion, the upper disc, and pi r2 square, this is the area of the lower disc. Again, L is given as under root of h square plus r1 minus r2 whole square. So, let us move forward and see how these formulas can be applied in the questions. A drinking glass is in the shape of a frustum of a cone of height 14 centimeter. The diameters of the two circular ends are 2 centimeter and 4 centimeter. Find the capacity of the glass. We are given that pi is 22 by 7. You can see here, this is a glass, right? And this is the bigger radius. The diameter is given as 4 centimeter. So, the radius will be 2 centimeter. Also, the height is given as 14 centimeter. This is 14 centimeter. Okay? Also, the radius of the lower disc, this is given as, diameter is given as 2, so radius will be 1 centimeter. See, the radius will be 1 centimeter. Okay? So, let us move forward. Since the glass is in shape of a frustum, this is a frustum of the cone. Therefore, the capacity of the glass means the volume of the frustum, and we find the capacity by the formula of the volume of the frustum, which we know is 1 by 3 pi h bracket r1 square plus r2 square plus r1 r2, where again r1 is the smaller radius and r2 is the bigger radius. Also, h is the height of the frustum. Let us substitute all the values and see. we have 1 by 3 pi h. What is R1? It is 2. What is R2? It is 1. So, substituting the values, also we substitute the value of pi as 22 by 7 and h as 14. Then what is the volume? Volume is 308 upon 3, that comes out to be 102 2 by 3 centimeter cube. Okay. So, the volume of the frustum of the cone comes out to be 102 2 by 3 centimeter cube. So, I hope this question is clear. So, let us move forward to our next question. The slant height of the frustum of the cone is 4 centimeter and the perimeters or the circumference of the circular ends are 18 centimeter and 6 centimeter. Find the surface area of the frustum. As you can see, we can make a frustum here. This is a frustum given, okay? And according to the question, what we have is the slant height of the frustum is 4 centimeter. This slant height, right? This is 4 centimeter, okay? Also, we are given the circumference of the circular ends. See, this is the circular end and this is also a circular end. So, the circumference is given as 18 centimeter and 6 centimeter. Clearly, 18 centimeter is the circumference of the upper circular end and 6 centimeter is the circumference of the lower circular end. The circumference of the circle is given by 2 pi r. Now, r is, what is r? R is the radius of the circle. So, we can find the curved surface area of the frustum, the complete frustum, by the formula pi r1 r2 plus into L, where r1 is the radii, r2 is again the radii and L is the slant height. So, let us move forward and substitute the formulas. Perimeter of the upper circular end. What is the perimeter? What do you mean by perimeter? Perimeter is the circumference. Perimeter is the circumference. The circumference of the upper circular end of the frustum is 18 centimeter. This is the frustum, right? And the upper end circumference is 18 centimeter. So, pi 2 pi r1 is equal to 18 and we can find the value of r1 as 9 divided by pi. Similarly, perimeter or the circumference of the lower end of the frustum. This is the lower end. What is the perimeter? Perimeter is 6 centimeter. So, substituting the formula, we have 2 pi r2 is equal to 6. So, value of r2 can be given as 3 by pi. Also, L, that is the slant height. This is the slant height. This is 4 centimeter. Okay. So, let us move forward. What is the CSA? What is CSA? The curved surface area of the frustum. It is given by pi r1 plus r2 into L. Substituting the values of r1, we have found it now, 9 by pi, and what is r2? This is 3 by pi. So, substituting the values, cancelling pi, we have 12 into 4, that is 48 centimeter square. So, the curved surface area of the frustum is 48 centimeter square. So, this is the frustum, this is the upper circular ring, this is the lower circular ring and this is the slant height. So, what is the curved surface area? It is 48 centimeter square. I hope this is clear. So, let us move forward. We have another question. A face, the cap used by the Turks, is shaped like the frustum of the cone. This is the figure of the face. If its radius on the open side is 10 centimeter, radius at the upper base is 4 centimeter and its slant height is 15 centimeter, find the area of the material used for making it. Area of the material used. If we want the area of the material used, we need the surface area. So, a face is shaped like a frustum of the cone. See, it is shaped like a frustum of the cone with radius of open side. This is the radius of the open side. This is 10 centimeter, right? and radius at the upper base, it is 4 centimeter. This is 4 centimeter. Also it is given the slant height is 15 centimeter. This is the slant height, or we can say this is the slant height, this is 15 centimeter. Now, since it is a face which is open at the other end, therefore, area of the material used will be curved surface area plus area of the upper base, right? Area of the curved surface area and the upper base. The area of the lower base will not be considered. Why? Because it is open at the lower end. So, let us move forward and put the formulas. CSA, or the curved surface area of the frustum, will be pi r1 plus r2 into L. R1 is the radius of one base, R2 is the radius of the second base, and L is the slant height, right. So, area of the circle will be, this is the area of the circle, the base is a circular end. So, it will be pi r square, where r is the radius of this circle, this is r. Okay. So, substituting with the formulas, we have slant height L as 15, this is 15, radius of open side, that is this much, is 10, and radius of the upper base, this is 4 centimeter. So, total area of the material used will be pi r1 plus r2 into L. What is this? This is the CSA of the frustum, plus pi r square. What is this? This is the area of the upper base. So, let us take pi as common. We have r1 plus r2 into L plus r2 square. Now, let us substitute all these values. We have pi as 22 by 7, r1 as 10, r2 as 4, L as 15, and again r2 as 4. Calculating this all and simplifying, what we have is 710 2 by 7 centimeter square. So, to make this face, the total material required will be 710 2 by 7 centimeter square. I hope this question is clear. So, let us move forward to our next question. A metallic right circular cone 20 centimeter high and whose vertical angle is 60 degree is cut into two parts at the middle of its height by a plane parallel to its base. If the frustum so obtained be drawn into a wire of diameter 1 by 16 centimeter, find the length of the wire. Here you are converting one solid into another. So, a metallic right circular cone is given, the height is 20 centimeter. See, the height is 20 centimeter and this is the cone, okay, and the vertical angle is 60 degree. This angle is 60 degree. It is cut into two parts with the help of a plane. It is cut out here and this is parallel to the base, right. The frustum so obtained is converted into a wire of diameter 1 by 16 centimeter. This is the frustum formed here. This is the frustum formed. This frustum is converted into a wire. What is a wire? Wire is in the shape of a cylinder. So, in triangle ABC, let us calculate, I will just delete this all. In triangle ABC, see ABC, this is a triangle formed, right, where EF is parallel to BC, this is EF, this is parallel to BC. Then AD is 20 centimeter, it is given that AD, this height, this is given as 20 centimeter. Also AG, AG is this much, AG, this is G, okay. So, AG is 10 centimeter. Also we have been given that angle BAC, this angle, this is 60 degree, okay. So, all these things are given, I hope you have noted it down. So, let us move forward. To get the values of the radii of both ends of the frustum, this is the frustum formed, these are the two radii, right, this is the frustum. Both ends of the radii will compare triangle ADB and triangle ADC. This is triangle ADB and this is triangle ADC. These two triangles we are going to compare. Again, AD is equal to AD. Why? Because it is common. And AB is equal to AC. Again, why? Because it is a slant height and L is common. The slant height is common. Also, angle ADB, this angle ADB, this angle is equal to angle ADC. Why? Because each of this angle is 90 degree. This is a right angle. So, these two triangles are congruent by RHS, that is right angle, hypotenuse, side. So, angle BAD, this angle, half of the complete angle. So, this angle 1, this angle 2, both are equal. Okay? So, let us move forward. Then angle BAD, we have seen this angle is equal to this angle, and we know this complete angle is 60 degree. So, each of this angle will be 60 divided by 2. What is this? This is 30 degree. So, this angle is also 30 degree and this angle is also 30 degree. In triangle ADB, we know this is triangle ADB. I will just mark it again, ADB. Here BD upon AD is equal to tan theta. This is BD upon AD is tan theta. Why are we using tan theta? Because it is a right angled triangle and we know the value of tan theta is 1 by 3. So, we will get the value of BD as 20 root 3 by 3. Why 20 root 3? Because AD has the value of 20. So, let us move forward. Now, in triangle AEG, this is triangle AEG. Okay. In this triangle again we are using the property of tan theta. So, we have EG, this is EG, upon AG, this is AG, is tan 30 degree. We know the value of tan 30 degree, it is 1 by root 3 and AG is 10 centimeter. So, substituting both, we have the value of EG as EG is equal to 10 root 3 divided by 3 centimeter. I hope this is clear. We have the value of EG also. So, let us move forward. Height of the frustum. What is the height of the frustum? This is a frustum, right? And we know the height of the frustum is 10 centimeter. R1, this is R1, right? This is R1. R1 we have already calculated as 20 root 3 by 3 centimeter. And what is R2? It is 10 root 3 by 3 centimeter. So, diameter of the cylindrical wire, we already know it is in the question. D is given as 1 by 16 centimeter. So, radius of the cylindrical wire is a cylinder. So, radius will be half of this, which is 1 by 32 centimeter. We have already found the radius of the wire now. Now, let us move forward and see the length of the wire. The length of a wire, let it be capital H. Since the frustum is drawn into the wire, then the volume of the wire will be equal to volume of the frustum of the cone. We will put the formulas. Volume of the cylinder is pi r square h and this is the volume of the frustum, that is 1 by 3 pi h bracket r1 square plus r2 square plus r1 r2. R1 and R2 are the radii, the two radii of the circular ends. So, let us find what h is, taking everything on the right hand side, keeping h on the left hand side, we get this. Now, what we have to do is, we have to substitute the values. We have to substitute all the values R1, R2 and h, and we substitute all the values, we get the value for h. What is h? H is the length of the wire, which comes out to be 7,964.4 meters. So, length of the cylindrical wire which has been converted from the frustum is 7,964.4 meters. I hope this question is clear. Okay? So, let us move forward. Let us summarize the whole lesson. We have studied, this is a frustum, this is the smaller radius R1 and this is the bigger radius R2 and this is the slant height L. Also, we have known that this is the height of the frustum. Now, we have already known the definition of the frustum. Frustum is a part of the cone. The volume of the frustum can be given as 1 by 3 pi h bracket R1 square plus R2 square plus R1 R2. What is h? H is the height of the frustum. R1 is the radius of the upper end and R2 is the radius of the lower end. Similarly, curved surface area of the frustum is pi R1 plus R2 into L. What is L? L is the slant height. We have a formula for the L also. L can be given as under root of h square plus R1 minus R2 whole square. Similarly, the total surface area can be given as the curved surface area, this is the curved surface area, plus area of the upper circular end and area of the lower circular end, wherein again the value of L can be given as under root of h square plus R1 minus R2 whole square. Also, you have studied about the application of these formulas in different problems. I hope all the concepts are clear. Here we end the chapter. Thank you.